Hi, welcome to Bulb and Bicker channel. We are doing a series of videos on the subject of Introduction to Electrical Engineering in the scheme. So, in today's class, we are discussing Kirchhoff's law. So in the previous class, we talked about many methods to simplify complex circuits, such as series, parallel, star, and delta transformation. Similarly, Kirchhoff's law is a method to simplify a complex circuit. There are two laws of Kirchhoff, Kirchhoff's current law and Kirchhoff's voltage law. That is what we are discussing in today's class. So let's take a look at it. In the previous class, we saw series, parallel, and equivalent, and also talked about star-delta transformation. What is that? We discussed a method to simplify a complex circuit. Similarly, a German physicist named Kirchhoff discovered a method to simplify a complex circuit. It is called Kirchhoff's law. This Kirchhoff introduced two laws. One is called Kirchhoff's current law, KCL. Kirchhoff's current law is known as KCL or point law or junction law. The second is known as Kirchhoff's voltage law or KVL or loop law. So, using this Kirchhoff's current law and Kirchhoff's voltage law, we can simplify a complex circuit. That is what we are going to look at further in today's class. So what is the Kirchhoff current law, what is the voltage law, and a few other things related to it. Before we get to Kirchhoff law, let's discuss some terms related to a circuit. So the first term is a circuit. Okay, we've heard it, circuit. Okay, what is a circuit? A closed path through which current passes, what we call a circuit. Suppose I have a circuit, let me draw a circuit here. Okay, I have drawn a circuit here. There is a voltage source, and there are resistors. The resistors are connected like this, and again here I have connected a voltage source again. I have drawn a circuit here. Okay, this is a circuit. Okay, let me mark this circuit, ABCDEF like this. So here is a voltage source V. Leave this, I denoted this as RVRT or. This is a circuit. Who is passing through a closed path? Question mark. A closed path through which current passes is called a circuit. We got the first term, we got what a circuit is. Now the second term, that is, in this circuit, now we know that there are some elements in the circuit. We know the elements in this circuit. There are passive elements, there are active elements. When you study electronics, what is a passive element? That is, the element that consumes energy is called a passive element. Resistors, capacitors, etc. are passive elements. When we say active element, we mean a voltage source, and when we say current source, the active element is the one that supplies it. Okay, now the term related to this circuit. What is a circuit? Now the first term is node. After we say node, we call the point where two or more circuit elements meet as node. So what are the nodes here? A is node, B is node, C is node, D is node, and this, not D, this is a node. All these are nodes. That is, since there are no two or more elements here, we considered both of these. What do we call the point where two or more subordinate elements meet? Node. So what are the nodes here? A is node, B is node, C is node, and this is node. Now the next point is the next term that we need to know in a circuit is junction. That is, we call the point where three or more circuit elements meet a junction. So what junction is coming here? Here we need three or more or. So B is a junction, and this is a junction, and B and E are called junctions. So what is node? What is junction? Now the next is branch. That is, the point between two nodes is what we call a branch. The circuit element between two nodes is what we call a branch. So what are the branches here? AB is a branch, and BC is a branch, and CD is a branch, then B is a branch, and AF is a branch. So what is the branch?
അടുത്തതാണ്
Then the next is called a loop, loop.
ലൂപ്പ്. ലൂപ്പ് എന്ന് പറയുന്നത്
After we say
അത്
loop, we mean a
ലൂപ്പിന്റെ
closed path.
പകുതിയാണ്
What do
നമ്മൾ
we
എന്ത്
call a
പറയുന്നത്
loop?
ലൂപ്പ് എന്ന് പറയുന്നത്. ഇവിടെ
What are the
എ
loops
ലൂപ്പ്
here?
ബി
ABEFA is a loop.
എ അതൊരു ലൂപ്പാണ്. അതായത്
That is,
ബി
ABEFA is a loop.
ഒരു ലൂപ്പ് ഒരു ലൂപ്പാണ്. ബി ഡി
The next loop is BCDEB, which means BCDEB is the next one.
ബി അടുത്തൊരു ലൂപ്പാണ്. ഇത് മൊത്തമായിട്ട് സി
The loop is a CDFA. A CDFA is a loop.
ഡി എ ലൂപ്പാണ്. ഇങ്ങനെ
So we
ക്ലോസ്ഡ്
call such a
പാത്തിനെയാണ് നമ്മൾ
closed path a
ലൂപ്പ്
loop.
എന്ന് പറയുന്നത്.
The next one is a mesh. What is a mesh?
ഏറ്റവും സ്മോളസ്റ്റ്
That is,
ലൂപ്പ്
the smallest loop which cannot be further divided or by which it cannot be divided is called a mesh.
ഡിവൈഡ് ചെയ്യാൻ പറ്റാത്തതാണ് നമ്മൾ എന്ന് പറയാം.
So which of these is a mesh? ABEFA means that the loop itself is a mesh but cannot be further divided. So which of these is a mesh? ABEFA is a mesh, and ABCDEB is a mesh. A CDFA is not a mesh.
അപ്പോൾ
What do we call a loop which cannot be further divided as a mesh?
മെഷ് എന്ന് പറയാം. എല്ലാ
So every mesh is a loop, but not every loop is a mesh.
മെഷ് അല്ല. ഓക്കെ
Okay, these are the basic terms related to a circuit. When we talk about some terms related to a circuit, like KCL KVA, we often use terms like branch, node, junction, principal node. So what is just a circuit? Only. Clear. Now let's discuss Kirchhoff law. So we said Kirchhoff law, we said two laws. The first law in it is Kirchhoff current law, KCL. So we said the terms related to the circuit. Now we discuss Kirchhoff law. If we say Kirchhoff law, we mean the two laws of Kirchhoff. The first law is Kirchhoff current law. So what is Kirchhoff current law? Having said that, the Kirchhoff current law says that the total
total current leaving from that junction. That
current entering the junction is equal to the total current leaving the junction.
suppose ഒരു junction ഉണ്ട്.
That is, suppose there is a junction and a current is coming into this junction. A current called I is coming here and a current called I is going there. So some current is coming into a junction. It comes here.
I3 ഇങ്ങോട്ട് വരുന്നു. നമ്മുടെ current
If for example, the current let it be I is coming here. These currents are all coming there. The incoming current is the current going there. If the current is going away. So what did Kirchhoff say?
total current entering ഈ ജംഗ്ഷനിലേക്ക്
Total current entering the junction means all the current coming into the junction.
leaving from that junction. That means അതിലേക്ക് വരുന്ന മൊത്തം current
What is the total current leaving the junction?
I3 which is
What is equal to?
എന്താ പറഞ്ഞത് I5. ഇതിനെ ഒരു സൈഡിലേക്ക് കൊണ്ടുവന്നിട്ടുണ്ടെങ്കിൽ നമുക്ക് എഴുതാം I1 I3 I4 minus I5.
What we said is that IFA that means how can we write it to one side i.e. I1P it plus I3 IFA I5V equals 0. This is what is called Kirchhoff's current law. Total current entering to the junction equal total current leaving from that junction. Clear now. For example, let's give a value for this. For example, a 2 ampere current is coming here. Similarly, a 3 ampere current is coming here. Similarly, let's say we don't know the value of the current set, i.e. now a 1 ampere current is going here. Similarly, let's say a 1 ampere current is going here. So if we can see the value of IE, how can we see that IE total current entering IE 2 ampere plus, then what ampere is entering plus IE, what is the total current leaving a plus?
അറിയാം. അതായത് I3 entering I4 is equal to 8 plus I3 equal to 40. So I3 equal to 40 minus 5 which is equal to ampere. അപ്പോൾ ലോ പറഞ്ഞത്രയും ടോട്ടൽ കറണ്ട് എൻട്രിങ് ടു എ ജംഗ്ഷൻ is equal to total current leaving from that junction. That means algebraic sum of current in a junction is equal to 0. ഇതാണ് Kirchhoff current law എന്ന് പറയുന്നത്. ഇതല്ലേ സിമ്പിൾ ആണ്. അതിന്റെ ഡെഫിനിഷൻ ഓർത്തിരിക്കുക. എക്സാമ്പിൾ ചോദിക്കുമ്പോൾ എക്സാമ്പിൾ വരും. രണ്ടാമത്തെ Kirchhoff law ആണ് Kirchhoff voltage law അല്ലെങ്കിൽ ലൂപ്പ് ലോ എന്ന പേരിലൊക്കെ അറിയപ്പെടും. എന്താ Kirchhoff voltage law പറയുന്നത്? The algebraic sum of voltage in a closed loop is 0 എന്നാ പറയുന്നത്. Suppose I have a circuit. സർക്യൂട്ട് ഉണ്ട്, റെസിസ്റ്റേഴ്സ് ഉണ്ട്, ഒരു സർക്യൂട്ട്.
E there is a voltage source, resistors.
വോൾട്ടേജ് വി എന്നുള്ള ഒരു വോൾട്ടേജ്
There is a voltage source called voltage V. There are three resistances there.
വോൾട്ടേജ് അക്രോസ് വി ടു വി ത്രീ. ഓക്കെ,
Is a
അപ്പൊ എന്താ പറഞ്ഞത്?
voltage.
പറയുന്നുള്ളൂ വോൾട്ടേജിന്റെ ക്ലോസ്ഡ് ലൂപ്പ് സീറോ. ഈ ഒരു ലൂപ്പിലുള്ള വോൾട്ടേജിന്റെ ആൽജിബ്രിക് സം എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ എന്തായിരിക്കും? സീറോ ആയിരിക്കും എന്നർത്ഥം. വോൾട്ടേജിന്റെ ക്ലോസ്ഡ് ലൂപ്പ് സീറോ എന്ന് പറയും. ഓക്കെ, നമ്മൾ നമുക്ക് പറയും V1 V2 V3. That means V1
V.
V2 V3 which is equal to 0 എന്ന് പറയാം. ഓക്കെ, ഞാൻ പറയുമ്പോൾ ഒന്നുകൂടി നിങ്ങൾക്ക്
That is, when we apply KVL. That is, if we say total voltage, then what will it be if we say the sum of individual voltages, that is, the algebraic sum? It means it will be 0. This is called Kirch's law of voltage. Let's discuss it with an example. Now, when we study this Kirch's law, that is, when we apply it in the problem, one of the most important points is called the sign convention. Okay, how do we give the sign? So what is the sign convention? So you remember in the sign convention, that is, the sign convention says this: if it goes from positive to negative, if it goes from positive to negative, what will be its sign? It will be negative. If the current goes from positive to negative, its sign is negative. Now the next thing is, if it's going from negative to positive, what will be the sign? Positive. Okay, the most important sign convention is that if the current is going from positive to negative, it's negative, and if it's going from negative to positive, it's positive. Now pay attention to the second sign convention, which is the entering current. That is, the point where the current enters, that is, the current entering point in a resistor. What will it be? It will be positive. The point where the current enters will be positive. Then the current leaving point, what will it be? It will be negative. Okay, this sign convention is the most important thing that we need to solve the problem. Remember, when current goes from positive to negative, it is negative. When current goes from negative to positive, it is positive. When the symbol of the resistor is given on the side where the current enters, when the sign is given, the point where the current enters is positive, and the point where the current leaves is negative. I will give you an example, then it will be clear to you again. So listen here, I have a circuit. Okay, there is resistance. Let's say there are 3 resistances. I have a circuit in which 3 resistors are connected to a voltage source. Here is the voltage source, here is okay. Then, here is the resistor. R, the voltage across this, the voltage across this. Okay, like that. Okay, I can give this today or tomorrow. Okay, I can give this today. Now let's see. We know the positive and negative of the battery. We know that the big ones are positive, the small ones are negative. There is no problem with positive and negative. Now what do? When we always give the sign convention, we mark the current in this. We take the current in the clockwise direction. Which direction do we always consider the current? In the clockwise direction. So I assumed a current in the clockwise direction. The current come in the clockwise direction like this and enter the current here. Don't you enter it in this part of the resistor? So here's the positive, that is, when the current comes in the clockwise direction like this, you don't need to look at any other symbol here, you don't need to look at any minus or plus. When it comes in the clockwise direction, this is where the current comes in. So here is the plus. How did that current get in here? It goes out here. In this part, minus. Then again the current has arrived here. Here we enter plus. Here we go down minus. Here we enter plus and here we go down minus. So, is it clear to give plus and minus to the resistor? Nothing. Assume the current in a clockwise direction. Give plus where you enter. Give minus where you leave. Plus minus plus minus plus minus. Is there any difficulty? No. Okay. Now let's see how to write the equation here. In order to write the equation, we need to look at the next thing. Look, what is the current going here? It is going from negative to negative and going down through positive. From negative to positive. When we say negative to positive, what is it? When we say negative to positive, it is positive. So this AVL is applied to the voltage drop. Now the next thing is from positive to negative. When we say positive to negative, it is negative. So what is the voltage there at negative?
V1 നെഗറ്റീവ്
1
V1
negative, 1 next from
അടുത്തത്
positive to negative?
പോസിറ്റീവിൽ നിന്നും നെഗറ്റീവിലേക്ക് അപ്പൊ എന്താ
So what,
നെഗറ്റീവ്
negative?
നെഗറ്റീവ്
Next from
V2
negative and
അടുത്തത്
positive to negative,
പോസിറ്റീവിൽ നിന്നും
this current is going from
നെഗറ്റീവിലേക്ക്
positive to
ഇതുപോലുള്ള ഒരു
negative and going down from
നെഗറ്റീവ്
negative.
ആക്കി പോകണം നെഗറ്റീവ് V2
So negative
equal
is
to
equal to 0.
0
That's what we said about the voltage.
നമ്മൾ പറഞ്ഞത്
What can we say about
ഇതിലോ
the voltage?
E is equal to നമുക്ക് എന്ത് പറയാം ഇത് അപ്പുറത്ത് പോയി കഴിഞ്ഞാൽ
If we take this
V1
further, then this is what I said earlier.
ഇതാണ് ഞാൻ
The
നേരത്തെ
algebraic sum of the voltage in a closed loop is 0.
0 ഓക്കെ
Okay, after saying that, what is it?
IR ആണ്
I
V
equals I,
equal
so
to
how
IR
can we?
അപ്പോൾ നമുക്ക്
Let's say I equals I here. What is the current here? Let's say I equals I here plus I equals I plus I equals I here. Okay, so we can do the current here in that way. This is what we call the voltage law. I will just give you one more problem with this KVL. Then what will you do, and you will get this sign convention again. Then the application of this is mesh analysis. When we do it in the next video, you will get another idea and the sign convention will be clear, how to apply KVL. Okay, so let's do a problem to understand KVL and its sign convention. Okay, that is, this is a question asked in a question paper. This circuit is given. Find current through 2.5 ohms. That is, we are told to see the current through this resistor, which is 2.5 ohms. Similarly, we are told to find voltage across 1 ohm, and also to see the voltage across 1 ohm. So let's see how to do it. What is the first step? After drawing this circuit, mark the current in it. In which direction will the current be marked? In the clockwise direction, then look at each of these meshes and each of our closed paths. The algebraic sum of each closed path is 0. So look here, I marked the current that says I1. So in this or this too, it is in the clockwise direction. So after the first step, mark the current in the clockwise direction, I and it. Now what do we give the sign? Give the sign to the resistor. For the battery, the big value is positive, the small value is negative, there is no confusion. Now let's look at the resistor. When the clockwise current comes, this is the part that enters. How did this current come into it? Here we enter plus, here we go out minus, here we enter plus, here we go out minus, here we enter plus, here we go out minus. This loop is complete. Now consider the next current I2. Then look at all the resistors. This current enters here plus, leaves here minus, enters here plus, leaves here minus, enters here plus, leaves here minus. Isn't it confusing? When considering this loop, this is the current to look at. When considering this loop, it is common to both. So it means that there will be two sides plus and minus. Isn't it clear? Now what do we do here? Let's apply KVL. So when we apply KVL, see how it comes. Apply KVL, that is, loop 1. Apply KVL to loop 1. Apply the first loop. Then turn the first loop up and see. Where do we start? I will start here. What is the sign convention from minus to plus, from minus to plus? The symbol for which direction it goes from minus to plus is apo. Plus apo, then from plus to minus, we should take minus voltage A, right? The voltage to be taken is V equal to V. What is IEA according to Ohm's law? What? Did they give us here? What do we have in our hands? Isn't it I apo then? If we say I, then we say I, then we say IEA, that is, 2IA. So what is the voltage to be written? There is no resistance value to be written. Dot. So what is here? Come on, from plus to minus, minus 2IA my IA. Then we got here, from plus to minus, minus IA. Okay, so are you sure that V equals IA always? Question mark. Now here, from plus to minus, then minus. But here, knock 1 ohm. One is coming here and one is coming here, it's opposite. It is common to both. When we take it, we consider this loop. When we take it, we consider this loop. If we do, look at it here. What is the resistance value and the current there? It is, because when we consider the first loop, it is from the plus, then the next one is from the plus.
Which is equal to 0.
What is minus 5 to minus 5, which equals 0? Now let's simplify this. My 2I1, my I1, my I1, my I minus plus pi I to MIFA equals 0. Now let's bring the I term first, minus 2I1 to 3I2, which is minus 5I1 then my I1.
then minus I1, അതായത് minus I1, minus I1, then to the term plus I2,
That is, my I1.
I2,
Then what is
then
the constant value of mi phi?
I12, എന്താണ്? So it
If we say so, plus v equals 0.
which is equal to
Now the constant is on the other side, we can leave the rest there. That is, minus 6 I1 pi I to minus 7.
which is equal to 7. Let it
Let it
be
be equation number 1. We got the first equation. That is, KVL was applied in loop 1. Isn't it clear to apply KVL?
apply KVL at loop 2.
Now apply KVLA loop to apply KVLA and apply KVA in the second loop.
രണ്ടാമത്തെ ലൂപ്പിൽ KVL അപ്ലൈ ചെയ്യാം.
Look,
നമുക്ക്
where do you
രണ്ടാമത്തെ
start when
KVL
applying KVA in the second loop?
ഉദാഹരണം ഞാൻ കൊടുത്താണ്.
Now, for example, I'm starting here from minus to plus. If this voltage source is common, take both places, except that there is nothing like that from minus to plus, plus, that is, from 5 to plus to minus, minus 1. When you consider this loop, you should write it as follows.
I2 minus I1 ആണ്. I2 I1 then പ്ലസിൽ നിന്നും മൈനസിലേക്ക് 4 I2
It is minus 1, then plus to minus, then minus 2.5, then plus to minus. What is minus, then 0? Okay, let's rearrange.
3 is equal to 0. Okay, അതിനെ rearrange ചെയ്യാം. I2 I1 4I2 2.5
It, how do we get
3 which is equal to 0. ഇനി I1 ന്റെ ടേംസ് ആദ്യം കൊണ്ടുവരും. ഇത് മാത്രം I1
it to be minus?
I2 terms minus 5I2
1 5.
2.5I2 അപ്പോൾ minus 5 7.
If you say
Then 5 minus 3 5 minus 3 എന്ന് പറഞ്ഞാൽ 2.
5 minus 5, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 7 minus 0, then what happens? If you say 4 minus 0, then what happens? If you say 4 minus 0, then what happens?
Number 3. Okay.
If you say 7, okay, multiply it and add the question number to this equation 3 and the same equation, that is, MISA plus I2 is equal to MISA.
Equal to
What is the equation number? Add these two together. When you add, what will happen? MISA will cancel out. Now my fo fa e2 empa ida, then what will happen?
അപ്പോൾ എന്താ പറയാ -4
My fo fa it uv is equal to my sam.
12 minus 7.
Then how many times will my sam? After adding it, you will get a minus. Okay, then what will happen? Naba 44F will come. 19B4 volts is equal to how many amps?
by 44.
Will
0.43 ampere.
come.
Okay, അപ്പോൾ നമുക്ക്
Okay, so we got the amps.
ampere കിട്ടി. ഇനി ഈ
Now if we substitute this amp into any of these equations, what will we get? We will get 1. Then we can substitute it into this equation. What do we say is POFAT? If we take it to the other side, we get 4 or 7.43. If we take this 7.43,
7.43 ചെയ്യുമ്പോൾ I1 7.43 by 6 ചെയ്യുമ്പോൾ നമുക്ക് 1.2
we get 1 or 23. If we substitute that, we get 1 or 23 amperes. Then we get 1 ampere. So we get 1 ampere. So we get 1 ampere. So we get 1 ampere. What did we want to see? What did we want to see? What is the current passing through 2.5 ohms? What is the current passing through 2 ohms? So we get 5 amperes. So we get 5 amperes. So we get 5 amperes. That is, the current that we said is 1 ampere. Now, what is the equation to find the voltage across 1 ohm? What is the voltage across 1 ohm? What is the equation to find the voltage across 1 ohm? Equals I here. What is the reason for the common ground between the two? If we say that I1, I2, I1, then it is 1 ohm. How much is I1, I2, I1? 1.23 if we say that I1.23 is how much is I1.23, then I4 asterisk A, then it is the same. If we say that I1.23 is 8 volts, then I 8 volts. Is this a problem in the KVN application? Now, there's a mesh analysis of this using a calculator, etc. We will do it in the next video. So, what we said so far is clear. So, what we said today is about the circuit and some terms related to the circuit. In it, there is just one problem in the circuit. Of